Hello everyone, I'm back. My name is Quentin Rossetto, and today I'd like to do a quick Vellum tutorial with you to make some falling leaves. It's fall season, it seems to be apropos. So let's get started. I'm gonna grab a new scene and we're gonna create firstly a reference character to have the correct scale. Let's get test geometry, template body here. And no, let's not talk about it ever again. Let's get another geometry, and within this geometry, we're gonna do our leaves FX. So, to start, let's modelize a really simple leaf. I'm gonna start with a grid. This grid is gonna be 1 by 1, only 2 rows and 2 columns, and let's rotate it 45 degrees. Let me hide the other guy for now. So we have a 45-degree square. Now let's get a bevel node. Let's put it as point, and let's work on point number 0 and 3. If I increase the distance, it starts to now on the side. If I add some more points, look at this. It looks like a leaf. Amazing. One more for good measure. Okay, so that's our basic leaf. Let's remesh it. And let's move it in Z positive. To do that, I'm going to use a match size and just change the justify Z to min. So now everything is in positive Z. Okay, let's put a null and call it leaf 01. Cool. We have our leaf. Now let's work on our emitter. It's gonna be another grid. This one is gonna be like 5-6 meters into the air. Bloop. There it is. Above my character. 10 by 10, fine. Let's drop a scatter. It's gonna scatter a bunch of points on our grid. I don't want that much. Let's say 3 points. Let's remove relax iteration. And we want to animate the seed so that it changes for every frame. Easiest way to do this is $F. With this, now every frame I have a different set of points on my grid. While I'm at it, let me check the real-time toggle so we have the correct speed, playback speed. And now that we have those points, if I copy my leaf right on it, copy to point, tac, tac, those leaves are gonna be huge. So I want to add 2 attributes on my leaf. First one is gonna be a p-scale. Let's drop an attribute randomize. Call it set p-scale. And attribute name is gonna be p-scale. Dimension, only 1 dimension, and for the distribution, I like the custom ramp. Let's change the size. Since our leaf original geometry is normalized, we can put here the scale of our leaf. I don't want any leaf bigger than 15 centimeters, and nothing smaller than, let's say, 0.7. Okay, those looks better. For the distribution, I'm just gonna go like this, so I have mostly small leaves and then a few big ones. Cool, so now my leaves have different size, but they all have the same orientation. To change this, let's drop another attribute randomize. We're gonna set the orient attribute. So attribute name orient. And orient is a quaternion, which means it needs 4 dimensions. So let's change dimension from 3 to 4. If I change the distribution to inside a sphere, now I can see that my leaves have different orientation for each frame. Great. Next thing I want to do is create a random value for each leaf so that I can change some parameter later, mostly the color. I'm gonna use a point wrangle for that. I'm gonna call this attribute rando, f at rando is equal to the rand function based on my ptnum as well as the frame, so it changes for every frame. Voila. That's set rando. And while I'm at it, I might as well do the same thing for the orient and the p-scale. So go to the set orient under option. Let's add plus $f to the global seed and do the same for the p-scale. Plus $f. So everything change every frame. Cool. So we have a bunch of leaves that appear a little bit everywhere. I'm gonna give them some color. I'm gonna do this after the copy to point. Let's drop a color node. And I'm gonna use the rando attribute to choose a color. So go for rem from attribute. Attribute is rando. You can also find it here. And for the color, let's start with a pale green, almost yellow. It's gonna go up to a brownish color like this. And in between, we're gonna have some nice deep red. Whoop. Some cute orange. And some nice and bright green. Voila, all the leaves colors. Let's even have a nice green at the bottom. So now we can see that all our leaves have different color. Cool. Let's mix a little bit those color. We can use an attribute noise float that we're going to put before the color. And what we're going to do is the rando value has been copied to all the point of our leaves, and it's the same value everywhere on the leaf, but I'd like to have some different shades on each leaves. So I'm gonna work on my rando attribute. It's a float. I'm gonna multiply the existing value and change the shade by 0.5. Let's change the element size. Go for 0.05, for example, and see if we can see some difference. Let me reduce the grid for now, 1:1, so all my leaves are at the same spot. They all look like they still have the same color. Let's see if I do some offsets. Do I see something? Not much. Let's go from 0 to 1. There is something happening, but it's not big, so let's increase the element size. Yeah, I can see stuff, but it's subtle. Let's look at the rando value. Yes, it's here. With the size, if I add some more contrast to it. No, I can see some difference here. Stop the rando visualization. Yeah. There is some stuff. There we go. Some are green, some are a little bit of yellow. Bit of everything, that's nice. Okay. That's to rando. And that's gonna be our source for sim. Source for Vellum. Okay. I'm gonna increase my grid again. So my leaves have a little bit more room to fall. And let's create our Vellum configure cloth. So Vellum cloth. I'm putting it right there. Put the view on it. Let's create our Vellum solver. Connect it. Look at it. The character is only here for reference. I'm not going to make it collide. And if I go back to the first frame, hit play, what's happening? It's amazing. I have like 3 leaves falling down. Ooh, amazing. And there is a few problems. First, there is no ground. That's the easiest one to correct. Ground position, them, so they won't fall for eternity. Second problem, well, I'm not actually emitting any leaves. I only have the one at the start and then nothing more. How can I solve this? It's pretty easy. You just have to dive into your Vellum solver. Here you have 2 outputs, force and source. Let's work on the source first. Let's create a Vellum source. With this Vellum source, what I can do is change the emission type and choose to emit every frame, each frame. Now I need to give him the sub path and the constraint path, so which are my geometry and my constraints. I can either put some null here and reference those nulls, or be smug about it and use the OP input path function. So let's put this little dingy OP input path, open the parentheses. So where is it gonna be? It's gonna be 2 level above, and it's gonna be 0 for the geometry. Let's close the thingy. And let's do the same for the constraint, and it's gonna be 1. Let's go back to the first frame and look at if it's working. It's working, and my leaves are falling every frame. Amazing. Okay, so now we have leaves falling. What's the next problem? Well, one of the problems I can see is they're falling pretty fast. I'd like to add some more air resistance. To do that, I could just go up and increase the air resist, the wind drag here. But I know I'm going to want some noise in my simulation and some winds, so I'm going to create here a pop wind. Voila. And the pop wind has 1 in air resistance, which should make them fall a bit slower. It's a bit slower, it's better, but we're not out of the wood yet. That's why there is leaves. One of the problems we have is, okay, they're falling. Nice, some of them are not falling straight out down, but you can see them slide through the air like some kind of spaceship. Woo! And they don't have those swirly, goody movement we're expecting of leaves. What's causing this movement? Well, basically it's 2 parameters that you have on your Vellum close. It's those 2 drag value here. The normal drag, that's gonna be the resistance when you're at a 90-degree angle from the face, and the tangent drag when you're when the face is parallel to the movement, which is why you can see them go slowly when they're more flat against the ground, but when they're oriented towards their velocity, they're just breathing through the air, just whizzing through it, not breathing. What can I do to improve this? Well, one of the things I can do is not have perfect leaves that are all so smooth and all the points are exactly on the same plane. So it's like some CNC leaves. That's not creating any different value of drags, and all the normal are facing the same direction, which is why we don't have those swirly pattern. What can I do to break this? Well, I can do, easiest thing to do would be a little point jitter. Point jitter takes the points and just move them around irrelevant of their position. So if I put a pointer here, we end up with some mess because the scale is to 1. I'm gonna want to reduce this a lot, like have something pretty light, 0.5, something like this. See, it's just adding a tiny amount, 0.25, tiny amount of movement on the points. They're not all perfectly flat, and that should already help a little bit. Let's see how it looks. It's slightly better. You can start to see some that go back and forth, but it's still pretty subtle. What can I do to improve this? Well, I can add something more than the point jitter. I can add an attribute noise. Attribute noise vector. What we're going to do is change even more the shape of our leaves. So we're going to work on a vector, and this vector is going to be P. Whoa, it's too much amplitude. So be sure you have 0 centered here. Let's reduce the size to something like 0.1 and reduce the amplitude to 0.05. Yeah, something like this. It's still a bit strong. You can see how it's completely deforming the leaves. Let's have it to 0.025. So that's modifying the shape of my leaf even more. Let's check the Vellum solver again. Now we're getting even better movement. See, some stay flat, other just go back and forth. This one here, the one in front, that's nicer. Go back, see a little bit. That's cool. Okay, that's already a better move for leaves. Let's see how fast they fall. 1, 2. I think they're falling a bit too fast, so I'd like to increase their normal drag. Let's go up to something like 40. And a bit the tangential drag also to 1. See how it moves now. Oh no, they're taking their sweet time. You want to have a nice difference between the two so that on one side they're slowing down really fast, and as soon as they align with their velocity, whoop, they're taking some speed and then slowing down once again when they turn a little bit more. Zip, zoop, zap. Let's see this. That's pretty cool. A bit too slow, I guess, for the tangent drag. Let's go slightly lower, 0.6. Cool. Yeah, I like those movements. Okay, and the first one arrived around 100, so they take 4 seconds to fall. That looks pretty good. Let's go back, let's play. Yeah. Yeah, that's good. What can we do to increase even more the different movement of our leaves? Well, we've seen that the normal drag and the tangent drag are the values that make them more or less slow down. What are those attributes? Well, you can find them on the point, drag normal and drag tangent. Let's add some attribute noise to it. Attribute noise float. Put it on this connection. Let's call it tune drag. I'm gonna work on the drag normal and drag tangent. I'm gonna multiply the existing value by something like no more than 25% of difference. And let's reduce the size quite a bit, like 0.5. That's gonna change slightly the value on each point of the leaves, and that's gonna make their movement even more, I was gonna say unpredictable, but it must be predictable since the computer is computing it. It's gonna make the movement more interesting. Zip zap zoop, leaves are falling, fall is coming. Pumpkin spice latte, yeah. Okay, so for the move of the leaves, we're pretty much done for those values. Let's just change one thing. When they fall on the ground, they're all getting really flat because we don't have much into the bend resistance. Like, let's look at this one here. Just fell down and push itself. So bendy. I don't want them that bendy. They're dry leaves. They're supposed to be a little bit more crispy. So let's go to our vellum cloth. And in the bend stiffness, let's increase this to something like 10. Up. That will make them keep their shape a little bit more on the ground. What can I do now to even more increase their the visual interest? Because now each leaf's doing their own thing, but they're all pretty much falling straight down. And if leaves are falling, it means that there must be a little bit of wind to get them out of the tree. So let's add some wind and some turbulence to draw some more swirly pattern in our sim. Let's go back into our Vellum solver. On our pop wind, I'm gonna add some wind velocity in the y direction, and I'm gonna add some noise to it. Let's go for 0.75. I want some large noise, so let's go for 4 in the swirl size. And I don't want the noise to change too fast, so let's go for like 5 in the pulse length. Let's go back, let's sim a little bit, see how it looks. Let me get in front of it, it's gonna be easier to see. And no, they're falling, and there is a little bit of movement towards the sides. And there is some noise bringing them together or making them move. That's pretty cool. That looks more natural, I guess. Let's sim a little bit more so that we can see what the next problem is gonna be. So they're falling down. That's really cute. But aha. Here is the problem. If you look at the leaves on the ground, well, the noise is still moving them, the wind is still pushing them on the side, and I don't want to see that. I want to see them move in the sky, but as soon as they're on the ground, I like for them to stay quiet. Let's play it, we're gonna see it even better. So the move, I think the noise is a little bit too strong. I'll modify this. And on the ground, you can see the wind is still pulling them on the side. So how can we fix that? Let's go back to our pop wind. Let's reduce this noise. And what we're gonna do, since we're working on a flat scene, we're gonna control the wind and the amplitude of the noise based on the point position in the y-axis. I want to have most of the wind when they're high, but as soon as they're under 3 meters, I want the wind to die down, the amplitude to go down, and when they're lower than 0.2, so closer to the ground at 20 centimeters, I don't want any more wind nor noise affecting them. How can I do this? Well, I can do this with a vex expression. What's the name of this parameter? It's wind x, wind y, wind z, so I can work on wind to affect them 3. wind multiply equal, so I'm gonna multiply equal it by the position in y at p dot y, but as it is, it's gonna be like times 6 when they're up there and 0 when they're down there. I need a little bit more control, so I'm gonna use a fit function. I'm gonna fit the position in y between 20 centimeters and 3 meters, and I want an output value of 0 to 1. So above 3 meters, they're gonna have 100% of the wind velocity, and under 20 centimeters, they're gonna have 0%. Let's copy this and do the same for the noise, except this time we're gonna work on the amplitude, which is AMP. Let's type AMP here. Go back to the first frame, get out of here, get out, and sim again. Yep. And see how it looks. They're falling down, we can see the wind pulling them to the right. But as soon as they get close to the ground, the wind is less affecting them less. And then they fall down and they don't slide on the ground anymore. That's nice. A bit more. Cool. Okay, let's see it real time. Oop. Oop. That's cool. Alright, me likey. That's cool. Last thing we can do is modify a bit their shape, because so far we only had one type of leaves. I'd like to have a few different. So how am I gonna do this? Let's go back to our prototype. We had one leaf. I'm gonna do some bendy on it. Let's use a bend node, put it there. Since our leaf is already in the z-axis and 1 unit in length, all I have to do is bend it, and I don't have to set anything else. Okay, so let's have one that's ever so slightly bent. Let's duplicate this. Let's have another one that's really bent. We can even have a little bit of twist on it. Let's have a third one with even more twist, like 45 twist. And let's go for 75. Random value, and the fourth one, just because this one is gonna be less bent, but quite twisted. Okay, so now we have 4 different leaves. Let's take them all and put them in a merge. Let's add a connectivity node and create an attribute that we're gonna call variant. Have a little null under it, and that's our leaves library. Cool. I'm gonna take this, put it in my copy to point, and if I look at what it's looking like, what he's doing is putting every leaf to every point. I only want him to put 1 leaf per point. So to do this, I'm gonna need an attribute from piece, put it to my source point. Second input is gonna be my leaf library. I'm going to tell him the piece attribute is variant. The mode is gonna be random. the seed is gonna be animated. And I'm gonna tell the copy to point. Now you're gonna use the piece attribute variant to choose which leaf to put on which point. Yada yada yada. Let's get back to one last simulation and see how it looks. So null under it. Out. Full screen. And let's simulate again. We're a bit far. Let me get closer. Look nicer. So. It looks pretty nice. We can see the leaves have different colors. There is some texture to it. They all have a slightly different shape. It's 4 different shape plus the point jitter plus the attribute noise that gives them slightly different shape. So slightly different aerodynamic properties. I don't know if it's a term, but since they're a little bit different, they move differently in the air. Then we have different value on their drag. We had on top of this a noise and a wind. And it looks like falling leaves. What else do you want? So, that was a speedy tutorial so that I can break my dry spell of 10 months. I'm happy to be back and I'll try to not wait as much for the next tutorial. Hope you like it and see you soon. Bye bye.